So now let's look at complex numbers. Complex numbers is a number set that is even larger than our real numbers, and the reason why is the complex numbers contain the real numbers as well as the imaginary numbers. A complex number is written in this form: a plus bi. The a is your real part of this number, and the b times I is the imaginary part of this number. So what's happening here? Well, I can have a complex number that is only real, or I can have a complex number that is only imaginary. How does that happen? Well, if I have 6 plus 0 times I, what is 0 times I? It's just 0, so you're left with only 6. That's a real number. So therefore, we have a real number as part of the imaginary numbers. Or I can have 0 plus 4i. This is the imaginary. 0 doesn't change it, so this is 4 times I. Thus, I have only an imaginary part. So my complex numbers can be a combination of real and imaginary. They can be only real, or they can be only imaginary, which is an important aspect of the complex numbers. So with my complex numbers, you're going to use the same principles that we have been using. You can add and subtract, multiply, and divide these. Today we're going to look at adding and subtracting, and then multiplying with a monomial, but not with a complex times a complex. So we're going to look first at adding and subtracting. And when you add and subtract complex numbers, it is exactly the same principles you have been using when you added 2x plus 3x, because 2x plus 3x are like terms, and you got 5x. Or 2 square root of 2 plus 3 square root of 2, and we got 5 square root of 2. So in the same way, 2i plus 3i is equal to 5i. So as you can see, we have all the same principles that are applied to our other systems that we have used. These same principles, adding and subtracting. Just like 2x minus 3x was equal to negative 1x or negative x, and 2 square root of 2 minus 3 square root of 2 was negative 1 square root of 2 or negative square root of 2. So 2i minus 3i is equal to negative 1i or just negative I. So we can add them and we can subtract them, just like we can any other like terms, because that's exactly what's happening with them. So now let's look at adding and subtracting like terms that are actually complete complex numbers. So let's do it. 6 plus 2i, there's one complex number, plus negative 2 minus 5i. Okay? Our like terms are 6 plus a negative 2, or 6 minus 2, which is 4, and my 2i minus 5i, because plus and negative is still minus, and that's a negative 3i. So it's just like any other combining of like terms. That's all there is to it. Now let's look at this as a subtraction. 6 plus 2i minus negative 2 minus 5i. Now, when we do subtraction, the first thing you're going to do is have to take care of my minus. So I'm going to distribute that to everything inside. So my 6 plus 2i will change. Negative 1 times negative 2 is a plus 2, And a negative 1 times a negative 5i is a plus 5i. So, now combine the like terms. 6 plus 2 is 8. 2i plus 5i gives me plus 7i. So as you can see, adding and subtracting is just like any other kind of like terms. Now let's look at a multiplication of a monomial before we add and subtract these, and watch what happens now. So let's do 3 times 4 plus 9i. Okay, 3 times 4 is 12, and 3 times 9i is plus 27i. And it's finished. So you're multiplying those numbers. Just like when you had 3 times 9x plus 4, it would have been the same thing. 3 times 9x is 27x. 3 times 4 is plus 12. So you can see it produces the same kinds of things that you've had before. So we've done our like terms, and we've done a monomial multiplication. Well, now let's do more than one of those multiplications and then simplify. So 5 times 2 minus 4i minus 3 times 6 plus 5i. That's what we'll go. So 5 times 2 is 10, and 5 times negative 4i is minus 20i. Negative 3 times 6 is minus 18, and negative 3 times 5i is a negative 15i. Now notice, like terms, 10 minus 18 is negative 8. Negative 20i minus 15i is a minus 35i. So you can add, subtract, multiply with a monomial, and there you have your complex numbers. As you can see, they function with exactly the same principles as many of the other things we have already done. So you simply apply it to this new concept. Have a good day.